Assalamu alaikum everyone. Welcome to another video of Chemistry with Sarab Tasambeg. In this video, we're going to write the electronic configuration of the first 20 elements. Let's look at the first 20 elements in the periodic table. And we are going to see that the first 20 elements are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. One thing you can see over here, and I'll write a note over here, that note that the periodic table is arranged in order of increasing proton number. The periodic table is arranged in order of increasing atomic number. In order of increasing atomic number. Like you can see, hydrogen has one proton in its nucleus, so hydrogen is the first element. Helium has 2 protons in its nucleus, so it's the second element in the periodic table. So the periodic table is arranged in order of increasing proton number or atomic number. Now, since hydrogen is the first element in the periodic table, it has 1 proton. And since we saw that the number of electrons will always be equal to the number of protons, so hydrogen will also have 1 electron in its duplet, and we'll just write it like 1. Helium has 2 protons, so it will have 2 electrons, we will write 2. Lithium has 3 protons, and hence it will have 3 electrons. The 2 of the electrons will come in a duplet, and 1 of the electron will go to the octet. Then beryllium has 4 protons, so 4 electrons. 2 will go in the duplet, 2 in the octet. And that's how I will fill the electronic configuration of the first 20 elements. So boron would be 2, 3, carbon would be 2, 4, nitrogen would be 2, 5, oxygen would be 2, 6, fluorine would be 2, 7, neon would be 2, 8. Now, after neon, you see that the octet is also full. You have 8 electrons in the octet. Now, you cannot add any more electrons in the octet anymore. So, now the electron will go in the third shell. So, 2, 8, and 1 for sodium, 2, 8, and 2 for magnesium, 2, 8, and 3 for aluminum, 2, 8, and 4 for silicon, 2, 8, and 5 for phosphorus, 2, 8, and 6 for sulfur, 2, 8, and 7 for oxygen, 2, 8, 8, and for argon. Now, 8 electrons are filled in the third shell. Now the electrons will go in the fourth shell. So 2, 8, 8, and 1 for potassium, and 2, 8, 8, and 2 for calcium. Now, very interesting thing to look at here is that if I talk about the groups and the periods of a periodic table, the groups of a periodic table are these vertical columns. Vertical columns. So group number 1, group number 2, group 3, group 4, group 5, group 6, group 7, group 8. And periods are these. This is a period. So periods are these horizontal rows. So periods, I will write here, horizontal rows. So period 1, period 2, period 3, period 4, period 5, period 6, period 7. So these are the periods of a periodic table, right? Now I would see that in group 1 I have elements lithium, sodium, potassium. So let's see lithium, sodium, and potassium. If I look at lithium, I have 1 electron in its outer shell. If I look at sodium, I have 1 electron in the outer shell. If I look at potassium, I have 1 electron in the outer shell. And that is exactly why lithium, sodium, potassium, rubidium, cesium, francium, they're all placed in group 1 because they contain the same number of outer electrons. So I will write another note over here that the number of outer electrons will signify the group number. So let's say beryllium has 2 electrons in its outer shell. Magnesium has 2 electrons in its outer shell. Calcium has 2 electrons in this outer shell. So beryllium, magnesium, and calcium would be in group 2. And that is the case. Beryllium, magnesium, calcium are in group 2. One very important thing we need to see is that the elements that have a full shell, for example helium in this case, helium in the first shell or first energy level, you have 2 electrons, it's full. Then you see neon, 2 and 8, duplet and octet both are full. Then you see, so helium, neon, and then you see argon, 288. The third shell is also full. These elements are called noble gases, which are found in group 8 of the periodic table. Except for helium, all these elements will have an electronic configuration that will end in an 8 because they are in group 8. So their outer shell will have 8 electrons except for helium. Helium is an exception over here. Helium has 2 electrons because it cannot have 8. But other than helium, neon, argon, krypton, xenon, radon will all have 8 electrons in its outer shell, and they have complete outer shells. So note, group 18 elements, group 8 elements will have a full outer shell or energy level. As we can see over here, as we can see, helium, neon, argon, they all have a full outer shell. So these, and for your syllabus purposes, group number 1, group number 7, and group number 8 are super important. They ask a lot of questions in the exam related to these group elements. These group 7 elements are called halogens. So I will also write that point. Note, group 7 elements are called halogens. And these halogens, as you can see, you have chlorine here, 7 electrons in the outer shell. You have fluorine here, 7 electrons in the outer shell. So these halogens have 7 electrons in the outer shell. Another very important thing to note is that the number of the period signifies, note, number of period signifies the number of energy levels. So you can see over here that if I'm talking about period 1 may you have hydrogen and helium. So period 1 just has 1 energy level. In period 2, you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So from lithium to neon all the way down there, you have only 2 energy levels. Then if you see period 3, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, they all have 3 energy levels. Again, coming to the note, number of periods signifies the number of energy levels. So this was all about electronic configuration of the first 20 elements and the important notes we had to see over here. In the next video, we are going to start the concept of isotopes and how to calculate the relative atomic mass of each element. Till then, stay tuned everyone. Thank you very much.